The quantitative data. This data can be described using numbers and basic mathematical procedures, including addition and are possible on the set, right? So the basic quantitative data, you can see whether a data is quantitative data if it can be represented with some numbers or with some basic mathematical procedures such as addition or subtraction. So this is the basic definition of a quantitative data, that it can be described by numbers or mathematical procedures. On the other hand, the qualitative data, this data cannot be described using numbers and using basic mathematical operations. This data is generally thought of as being described using natural categories and languages, right? So the two definitions basically defines a very straight line between the two types of data. One is the quantitative data and the other is the qualitative data. So if the data is being can be measured through some numbers, and if we could apply some mathematical procedures, then we can say that this sort of data is quantitative data. On the other hand, if we cannot measure that data through some numbers, or we cannot apply any mathematical operations on that data, then we can say that this is the qualitative data, and that will be described using some natural categories or language. Now let's see have an example. For example, we have some data related to a coffee shop, right? So the data which is related to a coffee shop can consist of the name of coffee shop. It can also include the revenue which is being generated maybe on daily basis or on monthly basis, and it can be in thousands of dollars. There will also be a zip code associated to that coffee shop, and there will be an average monthly customers which are coming to that coffee shop, and also there will be a country of coffee origin, right? So all this information or attributes will be related to that coffee shop, and it's combining making some sorts of data. Now let's see that which of these informations are qualitative data and which of this information is the quantitative data. Now the name of the coffee shop is the qualitative data. Why? Because the name of the coffee shop is not expressed as a number, and we cannot perform mathematics on the name of the coffee shop. So according to the definition of qualitative data, is that it should not be expressed by numbers or mathematics. So you can see that the name of the coffee shop is qualitative. On the other hand, if we talk about the revenue which is being generated by the coffee shop, then this is a quantitative term. Why? Because how much money a coffee brings in can definitely be described by using a number, right? So we can do basic operations on that numbers as well, for example addition or subtraction. For example, the revenue for 12 months to get a year's worth of revenue, right? So you see that the revenue can be measured, we can apply mathematical operations on that, and these characteristics brings it under the category of quantitative data. The zip code is qualitative. A zip code is always represented using numbers, but we cannot perform basic mathematical operations on a zip code, right? If we add together two zip code, it is a nonsensical measurement, right? So for example, I have a zip code from certain area and I have a zip code from another area. So if I add those two zip codes, it will be of no sense, right? So that's why we can say that mathematical operations cannot be applied on it, and it is a qualitative information or data. Average monthly customers, this is a quantitative term because we can measure that how many customers are coming into the coffee shop on a single day or a month or even a year. So it brings it under the quantitative category. Now the country of coffee origin is also qualitative because again we cannot have any mathematical operations on it and it cannot be measured. So that's why it is a qualitative information. So check for qualitative. There you can check these things to see that whether the data is qualitative or not. So the first thing you need to see is that can you describe it using numbers? If not, then it is qualitative. If yes, then we can move on to the next question. And the next question can be that does it still make sense after you add all them together? If they are not making any sense after the addition, then they are qualitative in nature. On the other hand, if they are making some sense, then you can say that most probably the data is the quantitative data. Another most common term which is used related to structured data and unstructured data is that whether the data is discrete data or the data is continuous data. So there is a very big major difference between these two types of data. Discrete data Discrete data describes data that is counted. So if we can count the total amount of data, then it is discrete. It can only take on certain values, right? So it is basically a finite set of data and there can be some certain values in it. Examples of discrete quantitative data includes a dice roll because it can only take on 6 values. So we have a set of values, a finite set of values, and that's why it is some discrete data. And also the number of customers in a cafe are the discrete numbers because you can't have a real range of people. On the other hand, if we talk about the continuous data, then the continuous data describes data that is measured, right? It exists on an infinite range of values, so it will not be a finite set, it will be an infinite set. For example, a good example of continuous data would be a person's weight because it can be 150 pounds or 197.66 pounds. So you can see that now we are going into the fractions, right? So we have some decimal numbers involved. The height of a person or building is a continuous number because a finite scale, because an infinite scale of decimals is possible, right? So if you have a bigger fraction, then there can be an infinite scale of decimals in this case. Other examples of continuous data would be time and temperature because it can vary a lot. Now let's see that what are the statistical measures or what are the statistical analysis that we can perform on different sorts of data. So one very important statistical measure that we perform on data is the sampling, right? So the question is that why we need to perform sampling. So our efforts and resources required to carry out the study on the population, right? So there are a number of problems or circumstances under which we need to perform sampling. For example, if we need to study a set of population, then we need to put in efforts and resources, right? For example, if we want to have average income of families living in a city, or we want to count the results of an election, or we want to know the opinion of different people for different problems, then all these things require a large set of population and will necessitate the use of sampling. So what is sampling? Sampling is basically the process of selecting a few or a subset of the whole data set from a bigger group, right? So we have a bigger group and the sampling population, and we are basically selecting a few of them or a subset of them, and we are doing this to become the basis of estimating or predicting the prevalence of an unknown piece of information, situation, or outcome related to the bigger group. So there are some advantages and disadvantages related to the sampling. Pros and cons are related to sampling. The pros are that it can save time because you are not working on the bigger population time. On bigger population, you are now working on a subset of the population. And the other advantage is in terms of resources. You can save resources, you can save financial and human effort as well. On the other hand, the disadvantage is that that we cannot have exact value of the population, and we only have an estimate or a prediction, right? So it is not an exact information, and we sometimes need to compromise on accuracy on our findings. So, if we look into an example of sampling, we can say that average student age in the university, average income, or maybe the result of an election can be good examples of sampling.